Section 5.4 is what we're talking about today. You may wonder what happened to 5.3. 5.3 is about side angle side congruency, and then this is in the middle of it. We've changed the order, so we'll actually deal with side angle side congruency next section with 5.5. So we didn't jump around and make a mistake here if this is intentional. Okay? So section 5.4 is on isosceles and equilateral triangles. Remind me, what was an isosceles triangle? Two congruent angles, two congruent sides. Equilateral triangle? All the sides are equal. There's a couple other terms then, vocabulary terms that we want you to be aware of. One of them is opposite. When someone asks you which angle is opposite a particular side, or which side is opposite a particular angle, we want you to think about which one is across from. So, if I ask you which side is opposite angle A, you are looking for the side that is across from angle A, not the two sides that form angle A. Make sense? Opposite means across from, remote to. Okay? Likewise, if I asked you for the angle opposite side AB, here's side AB, which angle is across from side AB? That would be angle C. Which angle is opposite side AB? Angle C. The reason that's important is we're going to define some sides of an isosceles triangle based on this terminology. So when we talk about an isosceles triangle, you told me that that's a triangle with two sides that are congruent, two angles that are congruent. In this drawing, in this figure, the tick marks mean that those are my two equal sides of my isosceles triangle. Those two equal sides are called the legs. So isosceles triangles have legs. The legs are the equal sides of that triangle. The non-congruent side, the non-equal side, is called the base. The base of an isosceles triangle is opposite those two congruent legs. The base does not have to be on the bottom. I can draw an isosceles triangle that looks like this and have two congruent legs, and these would be the legs, and these would be, this side would be the base. Okay. The two angles that are formed by that base are called the base angles. The two angles that share that base are the base angles. They are opposite the legs. So we have two congruent sides, they're called legs. Two angles opposite those legs called base angles. The third non-congruent side is called the base. We need to name the other angle, and that's called the vertex angle. So this would be our vertex angle of our upside down isosceles triangle. This would be a base angle, and this would be a base angle. Okay. The base angle theorem, yes sir. Stretching? Okay. The base angle theorem says that if two sides of a triangle are congruent, then the angles opposite them are congruent. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So when you have two legs of an isosceles triangle, the base angles will be congruent. So if I tell you that one base angle is 2x plus 40 and another base angle is 3x plus 22, can someone give me an equation that will help me solve for x? Excellent. 2x plus 40 equals 3x plus 22. The hardest part of geometry is getting the equation right. Then it's all algebra, and you guys can do that. Okay? We would take the 2x to the other side, move the 22 to the opposite side, and we get 18 is equal to x. Okay? Then always check the directions and see, do they want me to put that back in to find out what the angle measure is, or can I stop by finding x? And we didn't tell you either way here. Okay? Converse of the base angle theorem is also true. So if my base angle theorem says if two sides of a triangle are congruent, then the angles opposite them are congruent, what would the converse say? If the two angles opposite a triangle are congruent, or two angles of a triangle are congruent, then the sides opposite those angles is also going to be congruent. So if we have two base angles that are congruent, that forces the legs to be congruent. So I have two base angles that are congruent. That makes the legs congruent. Can someone give me an equation that will help me solve for x? Bet you will. Base angles are congruent. That means the sides are congruent. What does it mean when two sides are congruent? They're the same. So x plus 10, what? Mm-hmm. Mm-hmm. Minus 6, right? They're the same, so make them equal. When you think of same, just think equals and put an equal sign between. Very good. Then it's solving. The hardest part, again, is just coming up with the equation. Then it's just algebra. So x is 8. Then always check your original directions and see, did they want me to stop with x or did they want me to plug it back in? And pick the easiest one to plug into. They want the length of this side. There's the easy one. X plus 10, 8 plus 10, 18. Okay? All right, so here's another example. We have a total of 3 triangles here. A large triangle, and then 2 smaller triangles. And they want us to complete our statement here. So they said if HG, segment HG, is congruent to segment HK, then angle G is congruent to angle K. Okay? Very good, right? Except one slight problem. I'm good with saying angle G, and I know which angle K you're looking at, but how many angle K's are there here? If you include the straight angle, there's 3 of them, aren't there? So we need to make sure that we mention the right angle K. Anytime there's more than one angle there, we have to use that 3-letter combo. So what is the name of that angle K? Well, 3-letter combo gets me this angle. GKH or HKG. Either one works. Okay. Likewise, they can give me an angle measure. Notice they use a 3-letter combo here. KHJ, KHJ, because there's more than one angle H, is congruent to KJH. They could have gotten by with just calling this angle J. So these 2 angles are congruent. Based on the fact that those 2 angles are congruent, can someone tell me which 2 sides have to be congruent? Heard someone whisper it. HK is the side opposite angle J, right? And which other one has to be congruent to it? Here's my 2 base angles. Ignore the rest of it. HK and KJ, or JK. You can write it either way. Okay. And since I already had a single tick mark here, I could just use that same single tick mark. Turns out all 3 of those sides are going to be congruent. All 3 of those segments are going to be congruent. So far, so good? Okay. They like to give us great big giant diagrams because they can get lots of questions from those giant diagrams without having to print more diagrams and take up a lot of space in a textbook. So even though it doesn't look like it, based on how my projector's projecting this image, they're saying that segment NL is congruent to segment SL. This is a good time to have sticky notes. So if your parents have sticky notes at home and they don't mind sparing some, bring sticky notes with you. Because it's beneficial to be able to put that on top of the drawing, trace through it, especially the cheaper, thinner kind that you can actually see through, not necessarily the post-it notes. Put it on top, trace it, and then you can stick it to your assignment and you don't end up writing on your book. Okay, so you can make marks and show things are congruent and show the arcs to show the angles are congruent, and you can write on it and it's helpful. Okay, so raid your parents' office supply drawer. Okay, so if NL, segment NL is congruent to segment SL, NL, SL, these 2 segments are a part of this triangle. So ignoring everything else for the moment, if those 2 segments are congruent, that means that we have 2 angles that are congruent by the base angle theorem, right? And this converse. So which 2 angles are opposite those legs? And you can use the numbers. They put numbers in there conveniently so you don't have to use a 3-letter combination. Here are my 2 base angles, or my 2 legs. What would be the base angles of those two legs? 11 and 5. And that post-it can help because you can rotate the paper so the base looks like it's at the base, and you can see where those base angles are. Okay? So 5 and 11 are congruent because those two legs are congruent. Okay? How about if angle 1 is congruent to angle 4? First step, figure out which triangle we're referring to here. So 1 and 4 are part of this triangle. So they're the base angles. Which two sides would be the legs? MN and ML. Very good. Angle M is the vertex. Okay. What if angle 9 is congruent to angle 10? MR and MT. Does everyone see where he got that? There's my big triangle now. Those are the two angles in this large, large triangle. So if those are my base angles, then the sides opposite them are MR and MT. Very good? Okay. A corollary, something that's easily proven based on that theorem that we had, a corollary to the base angles theorem is that if a triangle is equilateral and the triangle is equiangular. Two big words. One's hard to pronounce. What does equilateral mean? All the sides are equal. What does equiangular mean? All the angles are equal. So if all the sides of a triangle are equal, then all the angles of the triangle are equal. The converse of this statement is also true. What would the converse say? Triangle is equiangular, then the triangle is equilateral. Because the converse and the conditional are both true, we could just write it as an if and only if statement. A triangle is equilateral if and only if the triangle is equiangular. Okay? 3 equal angles, 3 equal sides. All right, so here's an example, last example. They want us to find the values of x and y. What kind of a triangle is NLK? Equiangular, good. Since it's equiangular, what else is it? Equilateral. So what's y? Everybody agree y is 4? Okay. What kind of a triangle is LNM? Isosceles, very good. Base angles are congruent, right? So that means that legs are congruent. So how can we find out what x is? Awesome. X plus 1 equals 4. Why is it equal to 4? Yep. We have an equilateral triangle. All four sides are equal. That means, or all three sides are equal. That means they all equal 4. So x will be equal to 3. Okay. Your assignment is on the board. Page 256, 3 through 16, 23 to 24, and 42 to 44.